Welcome again. We're continuing with C++ operators. In the last video we looked at introduction to operators, then we just considered one operator, which is the assignment operator. Today we're going to be looking at the C++ arithmetic operators. So the C++ arithmetic operators are the operators for performing arithmetic operations like addition, subtraction, multiplication, division, and modulus division. So how do they function? The addition operator performs normal addition. 6 plus 3 gives you 9. The subtraction operator, as usual, 6 minus 3 will give you 3. Then the multiplication, which we use the asterisk, because x, which is the normal multiplication symbol, have another meaning, which is the character x. So in computing, multiplication is usually done by asterisk. So 6 asterisk 3 is 6 times 3, which is 18. Division, which is the backward slash, is 7 divided by 2.0, gave us 3.5. Then we have 7 divided by 2, gave us 3. Wow, why the difference? Is there any difference between 2.0 and 2? No, mathematically speaking, but program-wise, there is a difference. The difference lies in the data type. 2.0 is double or float, while 2 is integer. So when you do integer divided by integer, what you are performing is what we call integer division. The result is going to be integer. Then if you do any other combination, maybe integer over float, or float over integer, or float over float, integer over double, double over double, double over integer, any other combination, as long as it is not integer divided by integer, that is when you are going to get the normal division. So when we have 7 divided by 2.0, we got 3.5, which is the actual result. So many times you may have to do integer division depending on the problem you want to solve. The last amongst them is the modulus division, which is the percentage sign. What does it give us? It returns just the remainder after a division. So if we do 15 modulus 6, that should give us 2 remainder 3. So for modulus, it's only the remainder that is important to it. It will truncate the integer part of the result and gives you only the remainder. So what we have is 15 modulus 3 is 2 remainder, 15 modulus 6 rather is 2 remainder 3. That is why the result we have is 3. So we're going to go into the code blocks IDE to demonstrate these operators right away. Okay, so we have variables var1, var2, sum, div, and product as integer. They will have quotient as float. So let's demonstrate the arithmetic operators. First, let's look at the addition operator. So let's say var1 is assigned the value 23, var2 is assigned the value maybe 4, sum is equal to, or is assigned the value var1 plus var2. Say see out and say answer equals sum. No. Okay, so we have var1, which is 23, var2 24, var2 is 4, then sum is var1 plus var2, so 4 plus 23 should give us 27, so the answer should be 27. Good. Answer equal to 27. Answer is equal to 27. So that's addition for you. Just simple. So let's just do subtraction. Div. Okay. Let me just not remove it. Let me just copy and paste. See? Okay, diff is equal to this minus this. Answer is diff. So let me just use sum. Sum is diff equals to difference. So that's subtraction operator for you. Good. The difference is 19. The difference is 19, while the sum is 27. 23 minus 4 will give us 19. So let's go further. Let's do the product. PRDT, yes, is equals to this times. So say product. Let's see it again. Oh, catch me there. I didn't change what I'm printing, as I was still outputting sum instead of PRDT. Okay, let's run it again. Alright, 23 times 4 is 92. That's the product. Alright, I'm going to delete most of these codes so that I will go to division, because division, like we said, is a little bit trickish. Let's go to division. So let me okay, var1, var2. Let me take away these ones. Let me just leave this first now. Okay, let me say quotient. Quotient is equals to var1 divided by var2. Quotient is equal to quotient. All right, let's look at this. 23 divided by 4. 23 divided by 4 will give us what? Supposed to give us 5.75. Should give us 5.75. And let's see whether that will be the result. Wow, that's not the result. Why? Instead of 5.75, we are getting 5. The reason is because var1 is integer, var2 is integer. When you do integer divided by integer, the result is going to be integer, irrespective of what the left-hand side is. Even though the left-hand side is a float, it doesn't matter, because it was the numerator and the denominator are both integer. That was why we had that result. So let's modify now. Let's say 7 divided by 2. 7 divided by 2 should give us 3.5. But like we said before, the result is not going to be 3.5. The result is 3, because 7 is integer and 2 is also integer. So let's do it 2.0. Let's run it again. 7 divided by 2.0. It gave us the right answer now, 3.5. So any other combination will also give us 3.5. Float over float will give us 3.5. Float over float will give us 3.5. Float over integer will also give us 3.5. Any other combination gives 3.5, the right result. But when it is integer over integer, that is when the result is going to be integer, irrespective of the what is on the left hand side. Then another twist to it. Let's now say we want to place this value in var1. Don't forget that var1 is integer. var1 is integer. So let's now do 7.2. 7 divided by 2.0. We're expected to get 3.5. But let's see what the result will give us. Wow, the result is not giving us 3.5. Why? It's giving us 3. It's because the left hand side is integer. So look at the case here. If the result is decimal and the left hand side is integer, the left hand side will only take the integer part of the result. So instead of sending in 3.5, var1 will take only 3 and drop the decimal, because integers cannot hold decimal parts of a value. So that you have to be careful when you are doing division, so that you are doing what you actually want to do. Don't go and mix it up wrongly, because if that is money, imagine if you say 7, okay, let me just do something like this, and now say var1 equals to var1 times 1 million. Sorry, let me say times 1 million. Okay, let me use var2. So that I say var2 equals to var1 times 1 million. So well, let's print var2. So you understand the weight of this error. Okay? If you do 3.5 times 1 million, what you are supposed to get is 3.5 million. But let's now see what this result will give us. var1 times 1 million. Okay, I didn't end it with a semicolon. Okay, that's why. Let me correct that. Good. The result is 3 million. So imagine this is money. 500,000 has been wiped out just by your error. So that if to say it was quotient which we were using, and here we are saying quotient which is also float. Let's see the change in result, because we are using the right data type. Imagine 3.5 million. So you see what your error in choosing the wrong data type can cost. So if this was money, 500,000 has been wiped away just because of error in data type. So you have to choose your data type carefully, very carefully. And finally, I want to demonstrate the modulus division. The modulus division. Let's look at the modulus division. Let's say int x. Say x is equals to 23 modulus 4. What should be the result? 23 modulus 4 should give us 3, because when you divide 23 by 4, you get 5 remainder 3. So when we say C out x, we should have 3 as our result. Beautiful. 3 is the result, because that's the remainder. When you divide 23 by 4, you get 5 remainder 3. But why all this integer division? Why do they allow it? What's the need? Why not just do consistently normal division? There are cases where you might need it. Let's do a case of maybe a program to convert days. A program to convert days into weeks. A program to convert days into weeks and remaining days. So let's say int days, weeks, and R days. R days stands for remaining days. Okay? So that one will say, if I give you 18 days, you should be able to tell me that 18 days is 2 weeks and 5 days. 2 weeks and 18 days is, sorry, 2 weeks and 4 days. 2 weeks and 4 days. So how do we do such a program? So we are going to see how do we filter the week part of this program and the days part of the program. So to do that, I'll say weeks is equal to, let me just make it interactive. See out, enter the number of days. So I'll say C in days. So weeks is now equals to days integer division 7. Remember, when you do integer division, it will only give you the whole number. So if I say 18 divided by 7, 18 as integer divided by 7 as integer, the result is supposed to be 2. The result is supposed to be 2. So by that, I'm getting the weeks part of this program. 18 days is 2 weeks. So integer division will capture that for me. What of the remaining days? I will use modulus to do that. Modulus 7. If I say 18 modulus 7, that will be 2 remainder 4. But modulus will only give me the remainder, so it will give me 4. So by so doing, I've gotten the weeks to be 2, and I've gotten the remaining days to be 4. So I can now output. To make it interactive, I will say days is weeks and hour days So how will my output look like? To be interactive, the number of days I entered will appear here. So if I enter 18 as days, it will appear 18 days is whatever the result of the weeks. If it is 2, it will appear 18 days is 2 weeks and whatever the remaining days, which in this case 4, and 4 days. So I'm going to run the program now. Okay, if there's anything that is not right, we're going to look at it together. So let's see what it will give us. Enter the number of days. I enter 18. 18 days is 2 weeks and 4 days. Very correct. Let's see, 31 days. How many weeks? 31 days is 4 weeks and 3 days. Finally, let's just check 365 days, which is a year. 365 days. Of course, we know that 365 days has 52 weeks. So let's see. 365 days is 52 weeks and 1 day. So you can see that modulus division, integer division are not mistakes. They actually have their use depending on the problem you are trying to solve. That is what will determine how you use them. So we have come to the end of the arithmetic operators. We consider the addition, subtraction, multiplication, division, and modulus operation. Thank you so much. God bless you. Subscribe to this channel and like the video. God bless you.